Okay, so we're going to have a little recap on standard form, changing a number into standard form. So hit pause, copy the lesson objective and keywords down. When you're ready, hit play and we'll move into the starter. So here's our starter. Hit pause, have a go at the questions. When you're ready, hit play again and we'll go through them. Right, let's have a look at these questions then. Find 22% of 400 meters. Often with these percentage questions, we're often trying to find 10%. 10% of 400 is equal to 40. And do we need another 10%, or we double that one? Is equal to 40. So 20% is equal to 80. 1% we divide by 100. So that's going to be 4. I need one more 1%. It's also equal to 4. So altogether I've got 22% here, and that's going to be equal to 88 meters. Don't forget the units. 8 out of 20 as a fraction in the simplest form. So we write 8 over 20 as a fraction. And to simplify it then, what goes into 8 and into 20? Well, 4. So if we divide by 4, we get 5 here. And so we've got to, whatever we do to the denominator, we do to the numerator. And that's 2 out of 5. You need 12 apples. What's the best option for you? Well, there are a number of ways you can get 12 apples. You can do 3 of a pack of 4, so 52 times 3. Let's write that down. 3 times 4 packs. That's going to be 3 times 52. Let's work it out here. £1.56. Forget to write the 5 there. We could do 2 packs of 6. So if we double 65, should get £1.30. So we'll carry 1. £1.30. That's the cheapest so far. We could do an 8 pack and a 4 pack. So that's 74 plus 52. It's £1.26, is it? Yep. And that's the cheapest. And don't seem to be any other combinations. So that's our cheapest option. An 8 pack and a 4 pack. Okay. What's the distance between Exeter and Hull? Well, we've got to look at where these two intersect, and it's there, 305. We don't have any units, so we'll just leave it at 305. Got a couple more questions for you before you RAG rate it, but what I need you to do is make your corrections now. Okay, and then when you're ready, hit play again and we'll look at 3 more questions. Okay, so hit pause, have a go. When you're ready, hit play again and we'll go over them. Okay, what's the multiplier for a 10% increase? So that's going from 100%. We're adding 10 on, so it's 110%. And don't forget it's increase. So that's in decimals, 1.1 as a decimal. So that's our multiplier. Can you tell from the graph if there's more crime in city A or city B? So we've got city A here, and that's above city B. is there more crime? So we're looking for actual numbers, but we can't tell because this is just percentage growth, not the growth in numbers. So we don't know how many people are in city A or in city B, so we cannot tell. Cannot tell, as we don't know how many people, how much crime. In each city. Okay, good. Name the shapes. Right angle triangle. It is missing a little 90-degree angle there, but I think we can see that as a right angle triangle. This one, trapezium. Strange they're labeled B, E and G. And this one, I think the sides are the same. So it's not a parallelogram, it would be a rhombus. Okay. Now, I want you to rag, well, make your corrections and rag questions 1 to 7. Okay. So hit pause and do that. When you're ready, hit play again, and we look at standard form. We'll recap standard form. Okay, so in standard form, we can write numbers that are very large or very small. So it says here, write the number below in standard form. Well, we know because it's such a large number, the decimal point is going to be on the end. But we want to put our decimal point here, 4 point something, so 4.371 times 10 to the power. And we count where we've now placed the decimal point from where it was. We count forward and we get 4.371 times 10 to the power of 14, and that's standard form. You can write numbers that are very small in standard form. So there are a lot of zeros there, 0.000. So the same sort of thing, we want to write it as 5.83. So we can count backwards to where the decimal point was. And so we can write 5.83 times 10 to the power of minus 11, because we've counted backwards, it's negative. Okay, so let's write standard form in general form. So in general form, this is what we call standard form. We can write the number as a times 10 to the power of n, and a has got to be between 1 and 10. Okay, it's got to be smaller than 10, so it can be 9.9 something, but it can be equal to 1. Some examples of standard form are these. So 2.5 times 10 to the power of 3. You can see the number between 1 and 10. 1 times 10 to the power of 7. 1.1 times 10 to the power of 0. That sort of thing. 8.49 times 10 to the power of minus 45. So that's a very small number. What I want you to do is hit pause and write this definition down in the red box. Once you're ready, hit play again, and we look at an example. So we're going to write these as examples in our book. So if we write example here, whoops. First one is 56. So like I say, we're going to put our decimal point there. So that becomes 5.6 times 10 to the power of, and it moves forward 1 space. This one, I'm going to write it as 5.67 times 10 to the power of decimal points there. So we move it 1, 2, 10 to the power of 2, 567. Okay. And I'm going to give you one example with the smaller numbers. If you look here, it's 0.56. So we make it 5.6, but we count backwards. So it'll be 5.6 times 10 to the power of minus 1. What I want you to do is copy the examples and finish that off in your books. So hit pause, complete the exercise. When you're ready, hit play again, and we'll go through them. Okay, so let's see if we're right. On this one here, I'm going to put my decimal point there. So I'm going to count forward 1, 2, 3. So 5.678 times 10 to the power of 3. So I'm going to put a decimal point here and count forwards 1, 2, 3, 4. So it'll be 5.6789 times 10 to the power of 4. We've done that one. Here is going to be 5.6 times 10 to the power of, we count backwards, 1, 2, minus 2. Again, it's going to be 5.6 times 10 to the power of, when we count backwards, 1, 2, 3, minus 3. And the final one, again, is 5.6, decimal point goes there, times 10 to the power of, counting backwards, 1, 2, 3, 4, minus 4 because we counted backwards. Okay? So make corrections in your work, write classwork, and I've got a couple of questions for you to complete. Okay, so classwork, hit pause, copy and complete. Once you're ready, hit play again and we'll go through the solutions. Right, on this first one, it's 23. So where am I going to place my decimal point? There, between the 2 and 3, so that's going to be 2.3 times 10 to the power of, and we count forwards, 1. This one's going to be 2.34 times 10 to the power of 2. Here we got 4.585, counting forward, 3 times, 4.585 times 10 to the power of 3. Here, it's going to be 5.6789, looks familiar, 5.6789 times 10 to the power of 1, 2, 3, 4. 4. 4.6, well, we know something about this from indices. It's going to be 4.6. It looks like it should just stay as 4.6, but in standard form it has to be multiplied by 10. 10 to the power of what? Well, anything to the power of 0 is 1. So it'd be 4.6 times 10 to the power of 0. Here we've got 7.8. It's a small number. Times 10 to the power of, we're counting backwards, 1. Here we got decimal point there, so 5.3 times 10 to the power of, oops, sorry, that was minus 1 there. Counting backwards, 1, 2, so minus 2. And finally, decimal point goes there between the 5 and 6. 5.6 times 10 to the power of, counting backwards, 1, 2, 3, 4. So minus 4. So make your corrections. And when you're done, I've got some classwork, some more classwork for you. Okay, so your classwork, section 1, practicing skills, should not take you too long, and then you go on to developing fluency. Okay, so that's your job for today. I'll attach the classwork to your assessment, to your assignment even.